Okay, so this is page 10, and you guys, I know yesterday had done page 8 and 9, where we talked about how to use the calculators. Okay, and so now we're going to talk about this page 10, where you were asked to draw the z-scores. Okay, label the z-scores, label the context, and then the percentages below or around them. Okay, so I want you to know how to do this. So that's why I'm going over it with you. First of all, how many standard deviations go in each direction on a normal model curve? Well, if this is the mean here, how many standard deviations are there? 3 up and 3 down. Okay, good. All right, so we're going to label z-score first. And so, what is the z-score of the mean? Nope. The mean, nope, 0. The z-score for the mean is 0. And then, of course, we have our positive 1, our positive 2, and our positive 3, our down 1 standard deviation, our down 2 standard deviations, and our down 3 standard deviations. So those are the z-scores that I want you to label. All right. Then it says label the context values. So what is this problem about? Okay, so it's about shoe sizes. So we're going to put that here. So shoe size. All right. Now, what did it say that the average shoe size for males is? 10. Okay. So that's what is going here in the middle. And what is the standard deviation? 1.5. So we're going to go up to 11.5 and so on. And then I'm going to add another 1.5 and another 1.5. Okay. Then I'm going to be subtracting 1.5 as I go down. So I'm going to subtract 1.5, subtract another 1.5. Okay, so I just subtracted 1.5 each time or added 1.5 each time. All right, then finally it asks for you to do these percentages between each one of the standard deviations. All right, now the ones that we should know definitely by heart are the in fact, yeah, the 68, 95, 99.7, but we're going to even do more than that. Let me draw these up so that I can write on them. Okay, remember that within one standard deviation, that percent is our 68%. Okay, within 2 standard deviations, so 2 standard deviations is the 95% of the data. So 95% of all the data should be within 2 standard deviations of the mean. All right, and then do you remember what the last number was? Good, 99.7. So within 3 standard deviations is 99.7% of the data. Okay, so what I want you to do, and we had done this the other day, is I need this broken down into how much is in between each one of each one of the standard deviations. Okay, so for example, we said that these two were both 34%. Okay, so I'm going to give you a moment to figure that out again. So coming up with those percentages is something that you need to mathematically be able to come up with. That's like subtracting out areas and so on and so forth, okay? All right, so then you're filling in the rest. What proportion of males then have shoe sizes lower than 11.5? Okay, so if we want to do lower than an 11.5, that's, you know, all of this section here. So I need to know how much area that is. Okay, so you're just going to add up all those percentages. Now I'm going to probably make it easier because I'm not going to add up 1, 2, 3, 4. I'm not going to add up 5 numbers. I'm just going to add up 2 numbers. What 2 numbers am I going to add? What's below the mean? Yeah, so I'm going to add this part below the mean, which is 50%, and then I'm going to add to it this 34. See? Then I didn't have to do all of those numbers added up. Okay, you got it? So then that way I had 84%. All right, so I'll give you a few moments to do that, finish those up, and then we're going to get started on the next set of notes. All right, so take about 4 or 5 minutes max to finish that. On to page 11. All right, guys. Page 11 is not going to change much. It's just going to be where we find things that are written out all in context. So it's all about real-world stories. I don't just give you plain looking numbers like we had here. See, instead of just giving you plain looking numbers, there's words to it, and it's a real story. That's it. Okay, that's the only difference. Otherwise, then they are done the same way. So here we first say, okay, we want to find the probability for the following values. And we first have to turn our items, our context, into a z-score. So we're going to do that here. Let's look at example 1. Suppose that the average height in inches of females is 66 inches with a standard deviation of 1.75. Find the following probabilities of the female heights. So what I always like to do is start off putting down what I have. I'm pretty much going to list all of these things for every problem. Okay? So anytime I have word problems, I pretty much want to list those 4 things for every word problem. Let me get that in a color you can see better on. So that's the mean, the standard deviation, the x value, which is the context value, and then, of course, our z-score for standard deviations. All right, so this first one said that the mean of our heights for the females was how much? 66, with a standard deviation of 1.75. All right, so find the proportion of females less than 68 inches tall. What does 68 inches represent? Good. This is the context value. Context value, so that means it's the x. This mu right here is the mean. Is the standard deviation. Yeah, this is a lowercase sigma. Okay, that's the standard deviation. All right. Yes, that's going to matter. Well, we'll just write x equals 68 for now. Okay, so guys, look here. I want us to sketch a quick pic of what we want. And it's going to be as simple as saying the mean is 66, somewhere up here is 68, and I want to know the proportion of females less than 68 inches. So what part of this picture do I want shaded? To the left or to the right? Good, I want less than 68, so I'm going to do this section here. So that's what I'm trying to find. Okay, so for every problem, we're going to write down the data we have, we're going to sketch a quick pic, and then now we're going to compute it. So I need to find what this z-score is at 68. So how do I find that? Z equals x minus the mean over the standard deviation. X minus the mean over the standard deviation. So that means x is 68 minus the mean of 66 over the 1.75. Okay, so that makes us have a value of 1.14. And I always go to 2 decimal places. If you always go to 2 decimal places and you round them appropriately, then your answers will be the same as mine. All right. So yesterday we learned how to get this shaded area because you have to go from the lower bound to the upper bound. What calculator function did we use to do that? Second vars, and then what? Norm CDF. Good. Because the C gives you the cumulative area. So the norm, so you do not have to write this calculator strokes down here, but I'm writing it. Norm CDF. What is the lower bound on this problem? Negative infinity, so I represent that with a negative 99. Up to this upper z-score, which is 1.14. Yeah. You cannot put the x value in there. It has to be that z-score. So now you go to your calculator, and we are going to go then to second vars, norm CDF, number 2, from negative 99 to 1.14. And so 0.87, what was it, 2829? Okay, so then I'm going to write that in a percent. 87.29% is the answer that we are done with. So that means if you are a female that is 68 inches tall, you are taller than 87.29% of females. Okay? So if you are 68 inches tall and you are a female, you're taller than 87.29% of them. All right, so I want you to do that for B. Try that for B. See if you can do this one. The percent of females taller than 63. See if you can't try that one just the same way. All right, so let's kind of talk about this real quick. So you have some common sense things coming in here, okay? So I can start kind of instilling some fundamental thought processes. If your mean is at 66 and your x is below the mean, what kind of z-scores are down here below the mean? Negative. So it should not alarm you that your z-score is a negative value. Okay, so your z-score is negative because you're located below the mean. So when I norm CDF, how am I putting information into this norm CDF? What is the low end? What's the good? The lower bound is that negative 1.71 here, and what's the upper bound? Yeah, I'm going up to positive infinity, which I'm representing with 99, and so then that's how I'm getting that, which is, what's my total on that one? 0.95 what? 64? Okay. I'll look at that in a minute. All right, so that means if you are 63 inches tall, then 95.64% of females are taller than you. Is that how tall you are, Lexi? Are you 63 inches tall? Then 95.64% of females are taller than you. You could figure out yours for 62. That would be even more percent. Yes. Okay, now let's look at this last one here. What do you think is going to happen if I want to find out the probability that a female is shorter than 5 feet and taller than 6 feet? That's an in-between section. Okay, so if I was drawing a picture of it, then I know I'm going to have this area in between. Okay. What do you think about this 6 feet or 5 feet and 6 feet concept? Okay, how am I going to put that here on my picture when my mean is 66? Thank you. My mean is 66 inches. So I'm thinking I got to turn this feet into inches. Good. So I'm at 60 inches and 72 inches. So I'm going to draw them here. 60 inches, 72 inches, and I want to know the area in between those two things. So my mean is still 66. My standard deviation is still 1.75. What can you tell me about my x values? There are 2 of them. Good. So since I have 2 x values, what am I going to have z-score wise? I'm going to have 2 z-scores. I need to have a z-score for each one of those x's. Okay, so I want you to compute the z-score for 60 as an x and the z-score for 72 as an x. So you will have two z-scores. So do that now. Okay. Now, I just reread the question more carefully. And what do you have to say about my picture? Yeah, I drew my picture wrong. Because I am supposed to want, I'm supposed to want shorter. So I need to go out here to the left shorter than 60 inches and out here taller than 72. All right. So I could find those two areas and then add them up. Okay. I could find those two areas and add them up. How's another way I could do that that might save a little bit more time? Correct. If I found what this middle value is, then I could subtract it away from 100%. Okay, and then that would leave me with what's left. All right, so let's try that here. So I'm going to norm CDF from negative 3.43 to positive 3.43. Now, talk to me about how many standard deviations that is out. 3.43 down and 3.43 up. Isn't that like almost the whole entire normal curve? Yes. So that's important to notice it because watch what happens when I norm CDF that. From a negative 3.43 to the positive 3.43 is pretty much going to give me 100% of the data. See? 0.9994. So if 0.9994 is in the middle, then what's left on the edges? Yeah, 0.0006, which rounds to, let's turn that into a percent, 0.06%. That is teeny, teeny, tiny. Okay, so let me walk you through that math one more time.
Well, no, that's not correct. Like you did like 60 minus 66 divided by 1.7. I got 22.28.
Okay, so let me tell you one common mistake, guys, that I've noticed has happened in the past. If you're doing your z-score and you go 60 minus 66 divided by 1.75, what's wrong? Yeah, all that's getting divided by 1.75 is a 66. So you're messing up the order of operations right here if you're doing it that way. Okay, see that right there? Then you get something all messed up.
That's what I got.
Yep. Okay. Yes, ma'am. Okay. So the way I went from 0.9994 to 0.0006 is I did 100%, which is 1, minus 0.9994. So if I do that on my calculator, 1 minus 0.9994, I get oh, look at that. Is that how you get that? Okay, so maybe you would prefer to do 100 minus 99.94%. Ah, that's nicer. So either one of those ways you can do that. Now they are the same thing. Do you know that this little thing right here, 6 times 10 to the negative 4th, means move your decimal 4 spots to the left. 1, 2, 3, 4. Okay? All right. So there's kind of some stuff going on with the numbers. All right. Let's see here. What I want to do is have you do D, E, and F right now all by yourself, and then we'll check them. Here are the answers. I don't have all the work shown. Do you need the work shown? I mean, okay. So on E, you got to get, here's 66, and then you got 70 up here somewhere. And you want to go shorter than that, okay? So I'm going to find the z-score right here is 70 minus 66 over the standard deviation. And so that z-score is negative 2. Oh, wait, that doesn't sound right. Oh, that's why E's wrong. Yeah, positive 2.29. Oops, so see, that's my bad. Okay, so positive 2.29, which it shouldn't be negative, because if it was negative, it'd be down here. It's up here. Okay, at 2.29 standard deviations above the mean. All right, so that was my bad. So then I need to norm CDF. Okay, what is the lower bound of what's my lowest z-score? Good, negative 99 up to my 2.29. So it should be that. So it wasn't you, it was me. And then how much is that one? It's probably the opposite of that, right? Okay. Well, I rounded my decimals to 2. My lower z-score, I got, let's check me. My lower z-score I got was a negative 0.57. Is that what you got? So I just did it to 2 decimal places. So the reason yours is a little off and my taller one is 2.86. So what happens is if you don't go to just exactly 2 decimal places, then your numbers will be a little off from mine. They'll be close, but a little off, okay? So those were my z-scores that I norm CDF'd, and that's how I got that. If you got relatively close, then your decimals might be off. But if you want to have the same answers as me, then make your z-scores always go to 2 decimal places. And then you can have the same exact answers as me. Okay? Yes, ma'am. Yes. Okay, so this problem has a mean at 66 and you're going taller than 64. So that means this is a negative z-score. And so I did that value 64 minus 66 over the standard deviation, and I got negative 1.14. Okay, so then that would be the reason that you have a wrong answer. So you need to watch your, yeah. So that was my z-score. And then tell me what I norm CDF'd on this thing. So when I norm CDF'd, what is my lower bound on this picture? Negative 1.14. What is my upper bound on this picture? Positive 99. Okay. So you always just have to make sure that in your norm CDF, it goes from the lower bound to the upper bound, always in that order. Okay, questions on those? All right, then we're ready to move on. Okay, we're going to do, okay, so you can put that in the box. Let's go ahead and do one last thing, and it is a new calculator. Oh, well, here's an example. Hold on, this is, did I skip some? Ah, I skipped another word problem. Okay, gotcha. Okay. I tell you what. Yeah, let's go to this example 2 page, okay? Let's do. Actually, I think you could do this by yourself. So I would like to see you do example 2, and this would be the last one that we do. So do example 2, parts A, B, and C, and that'll be it for today. Let's see how you do on that. Hey, let's check these real quick, though. All right, so I wanted to show you the minimum amount of work that has to be shown. The work that has to be shown is actually this Z-score stuff and then the answer. You do not have to show, you guys listen up, you do not have to show the norm CDF stuff, but I have to see this Z-score formula with the items put into it, okay? That's a requirement even in my AP classes all the time, okay? So the answer that you would have gotten on A is 18.94%. If you did B correctly, you norm CDF'd from 1.75 was your Z-score to 99, and you got 4.01% as your answer. But I'm just not showing you the Z-score, but you need to have done that. You had to get 2 Z-scores on part C, and when you did that and you norm CDF'd between those two, you get 9.23% if you did that correctly. Now, one last thing. We're going to do D together before I let you go. Would you consider a bulb that lasts only 1,400 hours to be unusual? What should we think of as this mathematical definition of being unusual? Being an outlier. What is our outlier rule for standard deviation? If you are more than 2 standard deviations away from the mean, you are an outlier. So I need to go see how many standard deviations that is away from the mean. What is a measure of how many standard deviations? That's what your Z-score is. So you do the 1,400 minus the mean over the standard deviation, and that is negative 2.63. So would you consider negative 2.63 to be an outlier? Is negative 2.63 standard deviations down an outlier? Yes, because it is more than 2 standard deviations. So is this bulb unusual? I'm going to say yes, because it is more than 2 standard deviations below the mean. More than 2 standard deviations below the mean. All right. So it is unusual. It's more than 2 standard deviations below the mean. So we will start there at example 3 tomorrow and then learn one more thing that we will practice. So no homework.